So lesson number 4 that deals with factoring of, it's a difference of squares. It's just your difference of squares might have more terms in it. So the first thing to start off with is, how do I expand this out? So when I go to expand this out, I multiply the first terms together, and there's my a squared x squared. When I multiply the outside and the inside terms together, I get two expressions. So this outside term becomes abxy, and the inside term becomes a negative abxy. Because everything's being multiplied together, I can change the letters around. So I don't have to write it as axby and byax. I can rearrange the letters. These are going to cancel each other out. Something subtracted by itself will equal 0. So my outside and my inside terms are gone. That leaves with multiplying the last terms together. And there's my difference of squares. So from there, if I was to factor this, factoring means bring it back to its multiplying form. So there's my ax plus by and ax minus by. It doesn't matter if you put the plus term first or the minus term first. I generally put the minus simply because then I look at this again to see whether or not it could be factored. Because sometimes in the last lesson, when we were doing some of those differences of squares, we ended up with something that could later then be factored further. So if we look at class example number 1, I need to recognize what a difference of squares looks like. So in a difference of squares, each part in the terms is something that can be square rooted. I can take the square root of 9, I can take the square root of x squared, 16, and y squared, because they're all perfect squared numbers. So when I do that, this is what you should have come up with. Yes or no? Those of you that did those first couple of questions. So then if I look at b, well, right away I know I can't take the square root of 3. It doesn't work. And I can't do the same thing with 27. So before I start diving into a difference of squares, the one thing that I should always be checking is for a greatest common factor. Can I divide the first term and the second term by the same value? 3xy. I can take an x out of each term, I can take a y out of each term, and I can take the 3 out. So if I divide 3x cubed y by 3xy, the 3's equal 1. X cubed divided by x will give me x squared, and y divided by y will equal 1. If I do the same thing to the next term, 27 divided by 3 will give me 9. X divided by x is 1. Y cubed divided by y, I have y squared. Now if I look at those 3 terms, the x squared, the 9, and the y squared, are all of those perfect square numbers? So now I can finish this off with my difference of squares. So the 3xy still remains, it doesn't go anywhere. And now I have an x plus 3y and an x minus 3y. Now when I look at something like C can have a little bit of a trick to it. So what can you tell me about the numbers 144 and 4? Are they perfect squares? Yeah. But remember, what's the first thing we're always supposed to check for? Greatest common factor. Can I divide 144 and 4 by the same number? So they're both even. I know I can divide them by 2. Can I divide them both by 4? Can I take 144 and divide it by 4? What do you get? What I have remaining, is that a difference of squares? Yeah. because I can take the square root of 36 and all of these variables are all perfect squares. So I get 6pq plus r and 6pq minus r. Now, on this question, if you had started with this 144 and this minus 4 and you had factored that, this is what you would have gotten. But within each of those two factors, I can now remove a 2. So if I remove a 2 from this factor, I get 6pq plus r. Remove a 2 from the other factor. Everything here is being multiplied. So 2 times 2, there's my 4. So I would still end up at the same spot, provided that when I factored this part out, I recognize that I can still take out a common factor. So you could do this either way. So class example number 2. A pane of glass is rectangular and it has an area of 49x squared minus 16y squared square feet. The length and the width are both written in the form of ax plus by, where a and b are integers. Determine the values for a and b, and then write the expressions in x and y for the length and the width of the pane. It's a lot of wording in there to simply say, factor that expression. So take a moment and factor that for me. What do I get when I factor this?
7x minus 4y, 7x plus 4y.
This is a rectangle. By definition, a rectangle has parallel, opposite sides are parallel, meet at 90 degrees, and one set of parallel lines is longer than the other set of parallel lines. If they weren't longer, we'd have a square. It wouldn't be a rectangle. So looking at my expressions, which one of these two expressions do you think represents the length?
7x plus 4y.
And that would leave 7x minus 4y as the width. Really, it doesn't matter which one I would really let be the length and the width. Although generally, if we're talking about a longer amount, we'd probably start with that. Now, if x and y are negative values, I could be wrong. This could be a smaller unit. But generally speaking, chances are this one's going to be more so the length, this one could be more so the width. So then in part B, it says, given that the length is twice the width and the perimeter is 56 feet, develop a strategy for determining what the length and the width is. In other words, solve for x and y. Really what they're asking you to do. The length is double the width. So the length is equal to 2 times the width. And we said that the length was...
Can I have your attention, please? Power School is back on. Thank you.
So we have that the length is 7x plus 4y, 2 times the width, would be 7x minus 4y. pause this for a second. So that gives me an equation that represents the length being twice the width. What other piece of information am I given? The perimeter. How do I calculate perimeter of a rectangle?
2 length plus 2 width.
So 2 of the length, 2 of the width will equal the perimeter, which is 56. So 2 of the length plus 2 of the width. Oh, minus 8y. So if I expand this out and I remove the brackets, 14x plus 8y plus 14x minus 8y equals 56. Collect my like terms. 14x's and 14x's. 8y and negative 8y. Cancel out, which means they equal 0 this time. So when I divide, they would equal 1. When I subtract, they'd equal 0. So I get 28x equals 56. So what does x equal? 2. So now that I have that x equals 2, I could go back to this and I could solve for y. Wherever I see an x, I substitute in a 2. So I want you to take a moment and solve for y. Tell me what y would equal. So I have 14. Does this work if I try to put this together? Yeah, 14 plus 4y equals 28 minus 8y. I bring the 8 to this side, which makes it 12. 14 to that side. 7, 6?
Yeah.
Yeah.
So it's not a nice number, but it's still a number. Did I actually determine the length and the width of the window pane yet? No, I just determined what x and y are. The length from above was 7x plus 4y. X is 2, and y is 7/6. So that's going to be 14 plus 14 thirds. And 14 thirds is 4 2/3, so 18 2/3 of a foot. So now I'll give you a moment to do the same thing with the width. Solve for what the width would be. So instead of 14 plus 14 thirds, it would be 14 minus 14 thirds, or as a mixed number, 14 minus 4 2/3. Which would leave me with 9 1/3 feet. So this next part just looks at factoring difference of squares when the variables are no longer just an x squared. They could be an x to the power of 4, x to the power of 6, x to the power of 8. Kind of like what we did with the trinomials, or if I have a binomial in place. So there are some where you can do a substitution, but for class example number 3, we probably don't need to do a substitution in that one. Can I square root k to the power of 4? K squared. Can I square root 1? So if I factor this out, what would I get? I need to double check this. Always check if you have those binomials. Is that a difference of squares? K squared minus 1. So if I factor that out, what would I end up with?
K plus 1, K minus 1.
And now I've factored it completely. So if I look at B, 80 and 5 are not perfect square numbers, but do they have a common factor? 5? So what's 80 divided by 5?
16.
So now that I have this factored, do I end up with a difference of squares? Okay, so factor the difference of squares for me and tell me what you get. What'd you get, Addison?
4a squared minus x squared. 4a squared plus x squared.
Okay. Take a look at this one. Is it a difference of squares? So if I factor it, what do I get?
2a plus x. 2a minus x.
And then I still have my 4a squared plus x squared. So you keep carrying all of those factors down at each level. So the 5 doesn't go away, the 4a squared plus x squared doesn't go away. It will stay. Okay, look at C. Take a moment to see if you can solve for C. What would be the first thing I would do in C? Which is?
2p.
So if I remove a 2p from each term, what would I be left with?
P to the power 4, p to the power 4, minus 81, t to the power 4.
And is that a difference of squares? Okay, so if I go to factor this difference of squares, what would I be factored to?
P squared, q squared, plus 9t squared, and then p squared, q squared minus 9.
Do I need to do another step? Why?
Because the last one's a difference of squares.
Yeah, I have another difference of squares that I can factor out. So the first two terms would stay the same. First two factors. And then if I factor this out, I would be left with
pq plus 3t and pq minus 3t.
the last three examples. Look at how do I factor if I have an expression instead of just a monomial. And this could be where substitution becomes something that you may want to look at. So in this expression, the substitution that I might make would be for this b minus c. And I might even just say b minus c is going to equal x. So instead of an a squared minus b minus c squared, I'd have a squared minus x squared. When I go to factor that, I get an a plus x and an a minus x. Then I can put that b minus c back in. A plus b minus c and a minus b minus c. The last step would be to remove the brackets and clean up inside each factor. So when I go to remove the brackets of b minus c in the first one, because this is like a positive 1, the signs don't show a change. But when I go to remove the brackets on the second one, think of this as being a negative 1. Negative 1 times b will give me a negative b, but when I multiply it by c, I get a positive c value. So with something like b, you might choose to say, I'm going to let 2x minus y be my capital X, and my x plus y be a capital Y, or an A and a B, or something like that. So now instead of 2x minus y squared minus x plus y squared, I have just x squared minus y squared that I can factor and then substitute back in. So I'm going to let you try to finish this question off and see what you get. So when I factor this out, x plus y, x minus y, and then I put in what was x, and then what was y. And my last step would then be to remove brackets inside those larger brackets and collect like terms if I can. So I get 2x minus y plus x plus y in the first one. And when I remove the brackets on the second one, the x and the y's would become negative because I'm subtracting. I've got 3x here. The y's cancel. And then I've got x there. Right? The y's would cancel. So I'm actually left with 3x squared. Or did I do something wrong? Oh, yeah, it's supposed to be 2x minus y. That's what I did wrong.
I forgot about time change.
Forgot about time change. That happened 2 weeks ago.
Well,
didn't it?
I've been at my mom's, and then I haven't set my alarm at my dad's house. And I didn't think anything because it said 8:20 on my alarm clock for the alarm. It's like, oh, goody. But it wasn't goody.
There we go. 3x, and then this one would be x minus 2y. That's better? Now, if you didn't want to do substitution, you could still do the factoring without the substitution. If I look at this, I have something squared, something squared. So I know I can square root those. 36 and 49, are they perfect square numbers? And there's a subtraction in the middle, so this is a difference of squares. So if I square root 36, I get 6. Square root this x plus 5 squared, and I'll be left with x plus 5. And do the same thing to the other term with the 7x minus 8 squared, or 49 minus times x minus 8 squared, and I get 7 times x minus 8. And then I'd have the exact same thing written again, except this would be a minus. So 6 times x plus 5 minus 7 times x minus 8. So the sign that changes is the sign between the two terms, not within the brackets. And then I would remove my brackets by multiplying by 6 here, 7 in the next one, and now it would be a negative 7. And then the last step would be to collect like terms. 7x and 6x would be 13x. 30 minus 56, negative 26. Then I've got 6 minus 7 would be a negative x, plus 86. This term right here, if I want, because typically we never start off our binomials with a negative number. In all the binomials that we've seen, we've never had a negative. So I can either pull the negative out, or I can just reverse the two terms if I want. Is there anything that I can do with 13x minus 26? Divide both terms by 13, and I get x minus 2. So I could write it like this, or, remember what I said before, take out the 13 and take out a negative here. So it'd be like a -1, which would give me a -13 times x minus 2 times x minus 86. One of the reasons why we might write it this way is because then I've got my x's starting off each binomial. It's kind of the same routine. It's not necessary. You could have it in blue as well. So your practice questions, 1B, 2C, 3B, 4E, 5B, and then 7 to 10.